Hey guys, welcome to ELEC 2607. Today's topic is going to be Karnaugh Maps. We did like 3 hours worth of this stuff, and it doesn't take that long, so let's go ahead and finish this off. Well, what is a Karnaugh Map? Well, it's a simplified truth table. That's all it is. You have your inputs of A, B, and C. This is a 3-input truth table. And I just listed some of all the combinations over here. And just for this, remember that A is equal to 1, A naught is equal to 0, and this applies to all the variables. This will be important. Hence, this one right over here, which is 0, 0, 0, it can alternately be written as AB, A naught, or not A, not B, and not C. That's just what it is. Alright. A very important concept is how to write this down. Normally people write down as 0, 0, 0, 1, 1, 0, 1, 0, 1. If you do it this way, how do I erase that? If you do it this way, you're gonna mess up the Karnaugh map. So there actually is a way to do it, and the trick is to only change one bit at a time. So from here, we change it to 1. And the error here is you change the 0 to 1 and the 1 to 0. You can't do that in Karnaugh maps. You only have to change one bit. So how do you change one bit? Well, you can just put a 1, 1, and hence you only change that to that. Next is you just do the final one, and again you only changed one bit. That is very important. And hence it goes like 0, 0, 0, 1, 1, 1, 1, 0. And remember, every single one of these positions is just a combination of, it's like a multiplication table, this and that. Alright, well, I guess I already did this example, so let's put it over here. Well, what is that combo? Well, it's 1, 1, 0, right? Because 1, 1, 0, and you just match them up. And that is represented by A, B, C naught, right? Because 1, 1, 0. Okay, well, let's take a look at this guy over here. Well, what are its possible combinations? Well, this one is 0, 0, 0. This one is 0, 0, 1. This guy is 0, 1, 0. And this guy is 0, 1, 1. Alright. The next step, this is a Karnaugh map. We got some values. What do we do next? Alright. This is the long way, and the easy way will come afterwards once you get used to it. But how do you find the equation of this truth table? Well, the trick is to find out which column is constant. As you can see, C changes, right? It goes 0, 1, 0, 1. B changes as well. So the only one that is constant is A. And if A is the only one that is constant, then if A is the only one that is constant, what that means is the rest don't matter. A is the only one that influences the decision. Hence, the equation of this one is just A. Yeah, that's it. This is the map for A. Not. Aha! Tricked you guys, because A is 0, not 1. So this is the whole equation for the truth table. Yeah, you only care about what's constant. Alright, next we're going to talk about grouping things. Oh, and oh god, Microsoft OneNote is restarting. Well, that's bloody brilliant. And I'm just gonna, yeah, you crashed. Yeah, man, thanks. You were a great help. Recover copy. Alright. And we're back from the little technical mishap. Let's talk about grouping. And that looks like Grove. Group. So you can only group 2 to 0 and 2 to the n terms of ones. You can only group ones for now. Well, we'll get into others later. And where n is your number of inputs. Hence, if you have A, B, C terms, you can only group those terms because nothing else exists, and that's just a rule. So how many can you group? Well, it's 2 to 0 to the n. So you technically can go to 1 all the way to every single multiple of 2, or 2 to the n. Now, let's just do a practice and find the equations of this. How do you find out? Well, you look at what's constant. Well, if this is A and this is C, since A changes, it's insignificant. Since C changes, 0, 1, 0, 1, it's insignificant. So the only ones that don't change are B and D. Be careful, it's B naught and D naught because they're zeros. Alright, let's talk about grouping. So, imagine there were, I guess this is just more for rules. The different types of rules, right? You can group left to right, hence by this yellow. Again, left to right, hence by this yellow. And there's actually a little trick you can do, which is this trick. You go and you loop around. Whoop, whoop. And why does that work? Well, because you can only group one terms that are one digit away from each other. And by one digit, I mean, remember how it was 1, 0, like when we first started off this thing, if it's 0, 1, you can't group that with a 1, 1 because, you can't group that with a 1, 0 because 2 bits change. But you can group it with a 1, 1 because only 1 bit changes. So basically, if you have a 1, anything above it, right to the left and downwards, you can group it with. So that's why this loop around rule works. Because this one's down, remember it's kind of like a map, so if you think of a globe, it kind of loops around. This one's downwards is this one, because it's like a map. And this one should be self-explanatory, they're just left, they're in a little circle right there. And so why don't we just do an example and find out the best way to group. Well, what's the best way to group? Good question. The best way to group is having the least number of groups with the most number of terms. Quick example, if it was 1, 1, 1, 1, 1, 1, yes, you can group these two and these two and these two. Or you can group these 4 and that 2, and that reduces the number of groups and increases the number of terms in a group. Okay, well, why don't we do a Karnaugh map and find the equation of it? Sounds like fun. Woo! Alright, let me just kind of make this. Alright, so these are your 1s. I don't know why I drew little circles. 1, 1, 1, 1. Well, what's the best way to group this? Okay, well, 1 group, 2 group, 3 group. Well, that's one way of doing it, but it's not exactly the right way. If you remember, since it's like a map, you can actually loop around. So I'm going to highlight it for you so you guys can see. But that is 1 group. And the other one is this group. So, how do you find the equation? Well, let's do the slow way first. Let's talk about the yellow terms, 0, 0, 0 and 1, 0, 0. Since the A is changing, it's insignificant. So the only terms that really matter are B naught and C naught. Alright, we're done the yellow terms. Now let's talk about the green terms, 0, 1, 1 and 1, 1, 1. Again, A doesn't matter. So you're left with or B and C. And that is the thing of the whole equation. Well, that was really, really simple. Yeah, so why don't we just go to a more difficult one? And we have one over here. Now, let's try to group these terms. Well, that's pretty obvious. Oh, you can't trick me. You can do the loop rule over here and the loop rule over here. You know what? I messed up. This should be over here, and this one should be over here. Sorry. Yeah, you can't trick me. I tricked myself, but yeah, so you have 3 groups. Now I'm going to introduce a new rule just because I love pissing you guys off. And this is the 4-corner rule. And it states that if you have a 4x4 or any square, well, like 8x8 will also work, all the corners you can group together. Well, why is that? Well, let's talk about the term 0, 0, 0, and then you have 1, 0, 0, 0, and then you have 0, 0, 1, 0, and you have, last but not least, 1, 0, 1, 0. If you take a look at it, 1 bit changes, 1 bit changes, 1 bit changes. And if only 1 bit changes, you can for sure group them together. Alright, so you have that group. I don't know, I erased that. I'll write it out again. Because Control Z is too cool for me. That is not one of them. 1, 0, 0, 0, and I have left 10, 10. Well, which of these are insignificant? Oh, the ones that change are insignificant. So you're left with B naught and D naught. Now let's talk about these terms. Let's write them out. 0, 1, 0, 0 and 1, 1, 0, 0. Which one's insignificant? These guys. Only that one. So this term is B, C naught, or D naught. Or together with B naught and D. And that's the whole thing. Cool. Alright, a little bit trickier one. What is the best way to group this? Oh, you can do 6 at once. No, you can't. Remember, it's only 2 to the n. So 1, 2, 4, 8. 6 is not there. Sorry, fellas. Okay, well, how could you do it? I mean, I see that one, which is 4 big ones. I see that one, which is, I guess, another 4. And we can do that. Yeah, that's perfectly legal. Or we can choose. Yeah, I think that looks right. Jesus. 3 groups, maximizing number of groups, and you're allowed to reuse the ones. So yeah, why don't we go ahead and do this one as well? I'm going to start with this column. So this one is 0, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 0, 0. Clearly, only the ones that are constant matter. So you're left with C and D naught. Cool. Now let's talk about these 4. Alright. Well, you have 0, 1, 0, 1. That's this guy. The one below it is 1, 1, 0, 1. The one to the right of it, it's 0, 1, 1, 1. Right? 0, 1, 1, 1. And the one to the bottom of it, it's 1, 1, 1, 1. Well, which one is constant? That one's not constant. I erase stuff. That one's constant. It's 1, 1, 1, 1, 1. So the ones that clearly matter are B and D. Plus B, D. Now let's work with these 2 guys. Alright. 0, 0, 1, 1 and 0, 1, 1, 1. Which are the ones that stay constant? These guys. And which ones were they? They were C and D. And that's how simple Karnaugh maps are. And like, it's so much easier than choosing remember how we did Zor, how everywhere there was a 1, we'd write down the term like A naught, B naught, blah, blah, blah. Karnaugh map basically simplifies that and gives you a very simple equation. But remember, you have to minimize the number of groups and maximize the number of terms in the groups. And they go together. You can't just minimize the number of groups and have like 1 in all the groups. That's just useless. But you get a really nice equation in the end, and that totally works. And then you'll notice this guy. What happens when? But don't worry about that. Yeah, you can simplify it using algebra as well, but Karnaugh maps gives you the base. Finally, we're going to talk about. Whoa, what's that guy? What's this guy? Oh, right. All right. We're going to talk about the don't cares and the BCD, or binary coded decimals.